We're going to upload. There we go. All right. So to do our synthetic division, that is when we take our coefficients and our roots. I heard somebody say roots. You're right. What is our root here? -3. So we're going to have -3 on the outside of our synthetic division. And then what are our coefficients as we go across? 1, -1, 2, -4, and -8. So it's our coefficients as we go across. Our first term drops every time. What's going to go here? -3. Because we take what's on the bottom times our root. What's going to go here? -4. Because we add them together. What's going to go here? 12. And here? 14. Positive 14. What's going to go here? -42. Which means what's going here? -46. We're adding them together.
How did you do both?
We add, so we add our columns to get here, and then this guy times our root goes in the box.
Oh, okay.
Add, multiply. Add, multiply. So what's going under the -8? 138, which means what's our remainder? 130, positive 130. Yes.
Can you pause for a second?
Yes.
I just got on my phone. This is a lot, yeah.
It's a lot. It's part of the reason I always put it up in passive period. So we're going to use the same polynomial with the next one. So when you finish writing it down, look at the next one, see if you can figure it out.
We played at a bunch at camp, and I loved the thing, and then I had to leave, and I would listen to it, and I would be sad. But it's a good song to be sad.
Okay, it's going to have the exact same coefficients since we're using the exact same polynomial. So when we're setting up our synthetic division, it's the same stuff on the top. We're going to have our 1, -1, 2, -4, and -8. What's our root here? -1. I don't know why that arrow is pointing kind of up, but it is. So -1 is what's going right here. I wonder if that's going to lead us into what we're talking about today. Oh, snap. All right, so first term, drop it, which is a 1. What goes next? -1. 1 times -1 is here. Add down, and we get -2. What's going to go here? 2. Which means what goes here? 4. Which means what goes here? -4. Which means what goes here? -8, which means what goes here? 8, which means at the bottom we have 0. So our remainder is 0.
Can we just put, is it okay if you put like R of X equals 0?
Yeah, R of X equals 0. What does that mean about the factor X plus 1? It's a factor. This is a factor. X plus 1 is a factor of f of x. It's a factor of f of x. So we could use that to help us start factoring these polynomials. Which is what we're going to start doing like tomorrow. We're going to keep working with the synthetic division and practicing with it, but the factoring stuff is going to start coming up, so we're going to kind of just build our way up to it. The quiz on Thursday will have up to today's stuff. It's this Thursday. It's 4-1 and 4-2, which is up through today's stuff. So not what we do tomorrow. Tomorrow's stuff won't be on the quiz, but up to today's stuff. So it can have this stuff. So the factor theorem, which is real similar to the remainder theorem. Yeah. I don't, but my boss handed it to me. But my kids do.
Mostly a lot of black.
He promised her one yesterday.
Huh? Just about. We're doing Steve trick or treat tomorrow, so I'll be here. All right. So this is what we just talked about for the last one. If your remainder is 0, then x minus whatever it is a factor. So this is just having it written out, that it has a remainder of 0. This means, combined with our remainder theorem, the remainder is 0, which is 100% what we just talked about. Do I ever check your notebooks? No. It's your notebook. You do with it what you wish.
Would you write it down?
I would. I did. My copy.
Why do you have a copy?
Dude, who you think makes up these notes? I gotta work them through and make sure they function.
Oh.
If I didn't do the notes first, we'd be guessing. Which, as fun as that might be, would not be particularly helpful if I'm trying to make it up on the fly.
Who else is there?
Okay, so this is what we're going to work with today. This is still 4.2. I will go back. This is 4.2. Bless me. We should get through all of 4.2 today, no issues. I've got it as a page and a half, and usually we can get through 2 pages in the way that I write it. That's how I time it out. We get through 2 pages a day. All right. So it's very similar to what we did yesterday. We're going to find the quotient and the remainder. If f of x is divided by p of x, we're just going to use synthetic division because it's way faster. You could do long division if you are one of my friends who loves long division. Okay, friend. I'm going to say I'm pretty sure there's one who likes long division best. Synthetic's way faster, but lately do you. It still works. It's just faster. So what we're going to do is we're going to set up our synthetic division. We're going to take all our coefficients. 2, minus 3, 4, and minus 5. So we're setting up our synthetic division. What is our root for our P of X? 2. Synthetic division only works when we have a root. It only works when we have a root. So pretty much P of X has to be linear for us to be able to use synthetic division. If it's anything other than linear, we're going to have to use long division. First term always drops for synthetic division. What's going to go over here? 4. 2 times 2, giving us 4. Adding down in our columns, negative 3 plus 4. Okay. I couldn't tell if it was a question or just venting.
Just talking.
That's okay. What's going to go here? 2. Which means at the bottom, I was going to do that purple. Underneath that goes 6. So at the end here, we have, which means our remainder is 7. So our R of X, because we were asked to find our R of X and our quotient. Our R of X equals 7. The quotient, our Q of X, these are our coefficients down here. We're going to have our constant. This is our linear term, or our just x, and this is our quadratic term, x squared. So to write our Q of x as an equation, we're going to have 2x squared plus 1x plus 6. The synthetic division gives us our coefficients on our quotients. The easiest way to figure it out is to start this way and work this way. Constant x squared. And if it kept going, we'd have x cubed, x fourth, x fifth. So just go right to left, and it's constant, and then it keeps going up by exponents. Y'all, there's about 4 separate conversations happening right now, which is incredibly distracting for the people around you. If you don't care, that's way different from forcing your neighbor to not be able to hear. Thank you. Just a second, I heard a knock at the door, I thought. Never mind. What's that? Yep. Just keep going. So it would just be that so just gonna go right to left. So it's always your constant on this end, and x squared, it could be x cubed, x fourth, it just keeps going.
Okay, so for the 0, so basically like when 0 is like the remainder is just 0.
It's just 0. Yep.
It was like, I don't know why it made like a big explanation about like why like the remainder of 0 is 0, like
Right.
it's just 0.
It's just 0. They just like to get all fancy with their words. All right, we're gonna do this again, and again, and again, and again. So find the quotient and the remainder. If f of x is divided by p of x, we're using synthetic division again. So first thing I'm going to ask is, what's our root? 4. Synthetic is very, very fast. as long as we know what we're doing with it. It takes practice, though, sometimes. So walk me through our coefficients, left to right.
Oh, yeah, it's
3,
1,
0 for our x to the 4th, 0 for x to the 3rd, 6, 0 for the plain x's, and then 15. Watch the exponents. You don't get to skip them because they're not there. I have 0x to the 4th, 0x cubed, and 0 x's. So be super duper careful. It's really important that you get all your coefficients there. Okay. Okay. This one is going to have our most obnoxious numbers of the day, just to warn you. This one gets a little gross. First term drops, we know that, so 3 down here. So what's going to go here? 12. And then we add in our columns, bruh. And we get 12. I told you, this is the grossest. This is the grossest one. What's going to go here? 48. Adding to 0 gives us 48 again. What's going to go here? 192. Which means what's at the bottom? 198. What's going to go here? Close. 729.
Oh, we can't do calculator?
I mean, on the tests and stuff, we can't use a calculator. It's good practice for us, but I'm just going to double check us. Oh, 792. I'm the one that flipped it. You guys are right. Which means the answer is even grosser than I had. So what's going under the 15? Bleh. Ooh. There we go. Okay. So what's our remainder? $3,183. Like I said, this is the grossest one. So our R of X, our remainder, is 3,183. To get our Q of X, we take these numbers. This is our quotient. And we're just going to work our way right to left. This guy's my constant. This is my linear term. It's my just x's. This is my x squared. This is my x cubed. And this is my x to the 4th. Okay? I work my way right to left. It's the way easiest way to do that. You can also think of it as it's always going to be 1 degree less. So you could always just subtract 1x there, or 1 from your exponent there. Either way you do, it's fine. I tend to go right to left because I'm lazy. And I would just like counting better than subtracting and then subtracting and subtracting. It's just the way my brain works. So our Q of X, our quotient, that's an X. There we go. 3x to the 4th plus 12x cubed plus 48x squared plus 198x plus 729. 92. That's the third time I've done that. Holy cow. Thank you. Is this right now? There's not a time on it.
Yeah.
Okay. Belzy. I have no idea where that is.
Oh.
I think so. They didn't put a time on it, so I'm gonna go with yes? Question mark? Okay, like I said, this one's the grossest one. But questions on this one? Yes, dear. What do you mean? I mean, you could, but we're not going any further, so we're just going to get here and we're going to stop.
I thought we was gonna solve for that.
No, we're not solving anymore. We're just writing down R of x and Q of x, and we're going to stop. We will not, hopefully, gosh, I hope not, solve one quite that gross. Okay? So we're going to do, I think, one more of these synthetic divisions, and then we'll move on to other ones like are on the homework questions. Yeah. This is our last of the synthetic divisions for right now. So what is our root? 1/2. And it's okay. We can still do that with a fraction. It's totally fine. It works the exact same way. What are my coefficients going across? First term always drops, so our 4 is here. What goes under my first 0? 2. 4 times 1/2 gives us 2. We're going to add down to get 2. What's going to go under the 5? 1. Because 2 times 1/2. What's going to go under the 1? -4. So what goes under my next 0? -2. I'm going to get a different color here. So when we add that together, we get -2. What's going under the 1? -1. Keep forgetting to change colors. Which means my remainder is 0. So my R of x is 0. That means x minus 1/2 is a factor. Come on, green. So then to get our Q of x, our quotient, we've got our constant, our x, our x squared, and our x cubed. So our Q of x, we will write it as 4x cubed plus 2x squared minus 4x minus 2. Oh my gosh, same. Nothing, I'm just commenting on conversations. Okay, so the synthetic division, once we get the hang of it, it goes really, really fast. But not every question on the homework is a synthetic division problem, as fast as that might be. Because we get things like this one. Consider this polynomial, where k is a real number and x plus 2 is a factor of f of x. Find all values of k. We did one like this yesterday. Yeah. We're going to do 2 like this today and then 1 other kind of question. Okay? That's the plan for the next 15 minutes. This time they didn't give us an ordered pair to substitute in. Or did they? Because if we use that factor theorem that we wrote down right at the beginning, and I know this is a factor, that means what is the root here? -2. And if -2 is a root, what's its remainder? 0. Which means we know that f of -2 equals 0. So we have the ordered pair here of -2, 0. So it uses that remainder theorem to make the instructions more complicated. And now it's exactly like the one we did yesterday, where we substituted in 0 for the y, or for the function rule, and -2 in for the x, and we're going to solve for k. So we're going to substitute in 0 for f of x, and -2 in place of x, so -2 cubed, minus 3 times -2 squared, minus k times -2 plus 12. Does everyone see where all those pieces came from? There's a whole lot of stuff that went on in those first 2 lines. Yes, Jim. Because of that remainder theorem, if we know that x plus 2 is a factor, because that's what they told us, that means we have a root of -2. And the remainder theorem says if we have a root that is a factor, its remainder is 0. So y is 0 when x is -2. It's a really overcomplicated way of giving the instructions. But the book loves to overcomplicate things. So we're going to simplify this and solve for k. So we have 0 equals what? -2 cubed minus 3 times -2 squared. -2 squared is 4. 4 times 3 gives us 12. So we're subtracting 12. Minus k times -2. Plus 2k. Plus 12. The 12s cancel. Fine way to think about it. Add 8 to both sides, and so we get 8 equals 2k. So what does k equal?
4.
4.
That's all?
Once we get our brain wrapped around the instructions, the math part of it's not complicated.
I don't know why they complicate the instructions so much.
To be fair, they're getting you ready for calculus type questions, since this is pre-calculus, and calculus questions are so overcomplicated.
Why?
Because calculus.
Do they do it on purpose?
By default of what you're doing, it's overcomplicated.
Okay.
because of what you're doing, the instructions are very either super specific or super vague. So they're practicing having us have super specific, yet also super vague at the same time in questions. Because in calculus, you're finding volumes of odd three-dimensional shapes, like vases. So you'll find the volume of that or the surface area of that, and like, it's a whole lot of weird. It's a whole lot of weird. But they use overcomplicated questions. Like at some point you should read through my questions from my 600 level algebra course that I'm in right now. And it's overcomplicated yet underexplained. So it's good practice for that. All right, so we're gonna do another one very much like that. Except this time it's slightly more complicated. But it's still starting out the same way. X minus 2 is a factor of this, which means we know there is a root of what? Negative 2. And since it's a factor, we know that its remainder is 0. Which means the point negative 2 comma 0 is a thing in this function. So we're going to substitute in that point and solve for k. So 0 is my f of x. K times negative 2 squared. Nope, cubed. Plus negative 2 squared. Plus k squared times negative 2 plus 3k squared plus 11. So it's a little bit more complicated. Good? Cool. So we're going to have 0 equals, what's this first term going to be? Negative 8k plus 4 minus 2k squared plus 3k squared plus 11. You okay on those steps? Combine some like terms, and we're going to put it into a standard form order because it's going to hurt my brain if I write k squared at the end again. So we're going to have 1k squared minus 8k plus 15. Solve for k. Factor it. Exactly right. What's our pair of numbers that multiplies to make 15 and adds to make negative 8? Negative 5 and negative 3. So 0 equals k minus 5, k minus 3. And what are our solutions for k? K equals 5 and k equals 3. So there's two options for k. K could be 5 or k could be 3. We don't need to rewrite the polynomial with k in it. We just need to find the options for k. Okay? So when k is squared, it's a little different, and they again are overcomplicating the instructions. But it's just solve for k. Okay? One last problem for today. And it's a totally different vibe. No k. Do you need me to go back? Yeah. Okay. So the next question is we're going to find a polynomial and we're going to write an equation for it if I know its roots. Ready? Okay, cool. Just want to make sure I had enough time. So we're going to write the equation for a polynomial if I know it has a leading coefficient of 1, has a degree of 3, and it has zeros or roots of -2, 0, and 5. So it's kind of going backwards from what we did, where we had factors and we found our roots. Here we've been given roots and we're going to find our factors. How do I write a factor that has a root of -2? X plus 2. How do I write a factor that has a root of 0? X. Yeah, it's just x, or x plus 0. How do I write a factor that has a root of 5? X minus 5. If it has a leading coefficient of 1, I'm going to have a 1 here. F of x equals. What we're going to do is multiply those together. Multiply it out. Because we're going to practice putting it in standard form, because I know we're going to have to do that in a couple of days anyway. So it's good for us to remember how to multiply these at this point. Technically, according to the instructions that are on the screen, we wouldn't have to. But we're going to practice it right now because we're going to use it in a couple of days where we do have to put them in standard form. And we have the time to do so. If we were short on time, we wouldn't. So all we got to do is multiply this out. So do that. We're going to pick pairs and multiply. It's easiest to do things in pairs. It doesn't matter which ones we do. I'll just multiply these guys first. So f of x is x squared plus 2x times x minus 5. That one's easy peasy because it was a monomial times our binomial. Oh snap, throwing some old vocab at you. You can do this with distribution. You could box it however you want to. On this next one, I'm going to do with distribution. We're going to have x cubed minus 5x squared plus 2x squared minus 10x. And our final factor, or our final function, we're going to fix our like terms here. We've got x cubed minus 3x squared minus 10x. This would be our standard form equation. This is our factored form equation up here. Both of them are fine. In this particular set of instructions, it didn't say which form to be in, but I wanted us to practice the multiplying because it's going to come back up again in a couple of days. Okay? Yep. Just if I don't put that next page up, y'all complain to me that I never put it up. Yes, dear.
Can you type this? I'm like the any behavior with this and then alright. So
Yeah, because I'm going to do something that doesn't work here. Do x plus 1 squared.
on here.
On here. Instead of x plus 1, do x plus 1 squared. What does that change sign-wise? Because will you have a negative if it's x plus 1? No. It's only going to be positives, so that's going to change your positivity.
So this is -2.
Put parentheses around it. X plus 1 quantity squared. So, because if you see what that's changing, there you go. There you go.
what time is it?
44.
Oh god. I'll just bring it.
Yes, dear.
did you say was the standard?
Standard form,
Okay.
factored form. Mm-hmm.
Factor?
And factored form, this one down here, that we write just straight up whatever we write it with our roots, that's our factored form. Yep,
Thank you.
you're welcome. Always happy to clarify stuff.